Hello everyone. In this video, we're going to dive into the details of arithmetic in C++. Let's start with the notes for today. So our learning objectives are to be able to evaluate arithmetic expressions and learn more about typecasting and mixing different types in an arithmetic expression. So go ahead and start working on the warm-up task. Go ahead and open a file called arithmeticfun.cpp in gedit and code up an empty main function. And by now you should be getting a lot of practice doing this, so make sure you can do this all from memory, no notes. Hopefully that went well for you. Now that we have our empty main coded up, we're going to use it to practice working with arithmetic expressions and arithmetic operators in C++. So let's first start with a little bit of review about arithmetic. So you know a lot about arithmetic from your background in algebra. For example, if I were to write PEMDAS on the board, would you know what PEMDAS is an acronym for? PEMDAS is commonly used as a quick little way to remember operator precedence. So precedence is from high to low, where P stands for parentheses, and they have the highest order of precedence. E is for exponentiation, exponents. M is for multiplication. D is for division. A is for addition. And S is for subtraction. So parentheses have the highest order of precedence, and subtraction has the lowest order of precedence. Now, we know that multiplication and division are at the same level of precedence, and addition and subtraction are at the same level of precedence. So those are evaluated from left to right. Now, in C++, we have parens, standard parentheses that you would expect. We do not have an operator for exponentiation. We'll have to use a function from a math library in order to do that. We do have multiplication. It's the asterisk operator. We do have division. It is a slash, and it can be either integer division or floating point division, depending on what type the operands are. And then we have addition and subtraction, standard operators that you would expect. So just knowing this from your background in algebra, you can already solve pretty complex arithmetic expressions. So let's go ahead and head over to Arithmetic Fun, and let's just code up a little bit of practice working with these operators. So let's perhaps have a variable, let's call it x, and we'll initialize it to 5, and maybe we'll have an integer y that we'll initialize to 0. So we could assign x to be x plus 2. So that would be 7. The reason why is, let's say in memory, we have a variable called x. It's initialized to 5. And then we have x gives x plus 2. So the value currently in x is 5, is added to 2, which forms 7, and that overwrites x. So now x stores 7. The reason why the addition happened before the assignment is because addition is at a higher precedence than assignment. This time, let's not update memory. Let's just print out maybe like y minus 2. We'll use parentheses to group this arithmetic together. We get y minus 2, and it would be good to put in a little divider there. Y minus 2 is minus 2. 0 minus 2 is minus 2. There's no assignment on line 11, so this doesn't update anything in memory. Now, let's say we have a third variable. Let's call it z, and it's a double. And let's make it 5.0, some value, doesn't matter. And now, let's say x is assigned x minus y divided by z. Now, based on order of precedence, how is this evaluated? So it could be x minus y evaluated first divided by z, or x minus y divided by z, where the y divided by z occurs first. So you can always review PEMDAS to help answer this question. So since division is at a higher precedence than subtraction, it will actually be performed in the latter configuration, this one. Awesome. Okay, so this here is our first example of seeing division in our arithmetic fun.cpp file. And I want to take a moment and talk about division in more detail. So I mentioned there's two different types of division, right? There's integer division and there's floating point division. If at least one operand of division is floating point, I'll use FP as an acronym for floating point. Floating point division will occur. Otherwise, and in the otherwise condition, this would be both of the operands are integers. Integer division will occur. Okay, so let's start with floating point division. Floating point division is the standard division you've been working with your whole entire life. For example, if I said 1 divided by 3 equals what? And since we now know about the assignment operator, I won't use the equal sign. I'll just use an arrow. What does 1 divided by 3 evaluate to? So this evaluates to 0.33, 1/3. Now, in C++ world, both of these are integers. So since both of these are integers, this would actually evaluate to 1 divided by 3 integer division, which is 0. To ensure that you don't get 0 when you want 0.33, at least one of the operands has to be floating point in order for floating point division to occur. So that could be 1.0 divided by 3, 1 divided by 3.0, or both of them, 1.0 divided by 3.0. So why is 1 divided by 3 when both of the operands, integers, give 0? So this comes from the idea of long division, which is something you probably learned a very, 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 very long time ago when you were just a wee kid in primary school, in elementary school. So let's use a different number. Let's say we're going to evaluate 5 divided by 2. Let's do it first in terms of floating point division. 2 goes into 5 evenly 2 times with remainder of 1. 1/2 is a half, so this is 2.5. Okay, let's draw that out step by step. So 2 goes into 5. Evenly how many times? 2 times. Minus 2 times 2 is 4, leaves 1. 2 goes into 1 evenly 0 times, so we have 2, remainder 1. Now, the result of integer division is the number of times that this operand goes into this operand evenly. One does not go into 3 evenly, therefore 1 integer divided 3 is 0. 2 goes in, sorry, I wrote this wrong. Two goes into 5 evenly 2 times, so 5 integer divided 2 is 2. Let's do another example. Let's do, how about 10 integer divide 3. So 3 goes into 10 evenly 3 times. 3 times 3 is 9, minus 9 is 1. 3 goes into 1 evenly 0 times, so we get 3, remainder 1. This 3 right here is the result of 10 integer divide 3. Now, I think we're pretty good on floating point division. When at least one of the operands is a floating point type, like double or float, then it will evaluate to the standard floating point division that you've been used to your entire life. This here, on the other hand, is a little bit different to think about. If both operands are integers, then it's going to be the whole number of times that this operand goes into this operand evenly. Now, I'm going to go ahead and erase this over here to talk about another operator that is commonly used in programming languages like C++. And this is called the modulus, aka mod, aka remainder operator, and it's a percent sign. So the mod operator essentially gives you the remainder of integer division. So for example, 1 mod 3 is 1. 3 does not go into 1 evenly, remainder 1. 2 goes into 5 evenly 2 times with remainder of 1. So 5 mod 2 is 1. Ten mod 3. 3 goes into 10 evenly 3 times with remainder of 1. So this is 1 as well. Let's try another one. Let's do, how about, let's say 7 mod 4. Go ahead and try and solve 7 mod 4. Pause the video. All right, I'm gonna go ahead and solve this. So we do integer division first. 4 goes into 7 evenly 1 time. 4 does not go into 3 evenly, so we have remainder 3. So we'll use integer division mod a lot this semester. Really easy example to describe some use cases for when mod is useful or helpful would be determining if a number is even or odd. So any number, mod 2, if it's even, will give you a result of 0. If it's odd, will give you a result of 1. Go ahead and show you that. So let's say we have 1 mod 2 is 1, 2 mod 2 is 0, 3 mod 2 is 1, 4 mod 2 is 0, 5 mod 2 is 1, so on and so forth. So it just keeps alternating. So every odd number, mod 2, will give you 1, telling you that it is in fact odd. So let's quickly code up a little bit related to doing some integer division. So let's do, how about 13 mod 10? See if you can guess what this will be. 3, 10 goes into 13 evenly 1 time. Let's say we're going to compute the volume of a cone for a radius of 5 and a height of 10. So we would have 1/3 times 3.14 times 5.0 times 5.0 times 10.0. And note what's going to happen right here. So it prints out 0 because remember, if both operands of division are integers, then integer division will be performed. So this here, 1 divided by 3, always evaluates to 0. At least one of these has to be floating point in order to give you the result you would expect. Now, we've talked a little bit about typecasting. We saw static cast a few videos ago. We saw what happened when we assign a higher precision number like a float or a double to a lower precision variable like an int. We saw the truncation that can occur. So if this happens to occur during an arithmetic expression, for example, instead of assignment, you're doing an addition between a double and an int, the result is always going to be the more precise data type. So here's some examples here where we have 3 integers and we have 2 doubles, and we're kind of mixing them together. So like a double plus an integer is going to be a double, but then it's going to be saved in an integer. So that implicit conversion from a double to an integer will occur, which we saw a few videos ago, and the value will be truncated. So these are some good examples to work through, and make sure that you understand what happens when you have mixed types in an expression and what happens when you assign a value of a different type to a variable. Here's the static cast that we've already seen and the implicit cast that we've already seen. Here's an operator precedence table that I highly recommend you keep around when first beginning to solve arithmetic expressions computationally. This table has the highest order of operations at the top and the lowest at the bottom. So for example, here is our assignment operator, and it has lower precedence than our arithmetic operators up here. Here's multiplication, division, and mod. Mod is at the same level of precedence as multiplication and division. We haven't learned about these operators down here or some of these operators here, but we do know about unary plus and minus, like you would use unary minus to negate a value, and we learned about cast already. So we'll learn about these relational operators and these logical operators soon when we start to talk about conditionals. They're very important. And lastly, here's a more complicated example that I highly encourage you to work through. So say we have this expression z minus paren a plus b divided by 2 paren plus w times negative y, and here are your values, which are all integers. You can work through this and evaluate the result for z. It'd be a really, really good, evaluate the result that this would be perhaps printed or assigned to if part of a cout statement or an assignment expression. So I highly recommend working through this example, and you can always just head over to C++ file and code up some examples. So maybe make up some examples, solve them on paper first, code them up, run them, and you can check your results. So lots of good ways in order to practice arithmetic in C++.